Hi, Dia. We're going to go through the problems you missed so that you understand them. So I already went through and kind of looked at everything. On this very last one that you missed, 24, it was just a rounding. Like you put 15 instead of 15.2, 66 instead of... So I went ahead and gave you that point. So it's not counted against you since you obviously did everything right. It was just a rounding issue. So I wanted to say that first. Okay. So let's start with number 8. And this is the one you emailed me about. So it says, in one town, the number of pounds of sugar consumed per person per year has a mean of 8 pounds. So this is for number 8. The mean is 8 and a standard deviation of 1.3. So it says Tyler consumed 11 pounds of sugar last year. How many standard deviations from the mean is that? Okay, so we're going to find the z-score of 11. So remember the z-score formula is x minus x bar over s. So we're going to do 11 minus 8 over 1.3. And just remember to put parentheses around the numerator when you do it in your calculator. So 11 minus 8 divided by 1.3. And we always round the z-score to 2 decimal places, so this would be 2.31. Now, since this is positive, that means it's above the mean. So so that's why the answer is B here, 2.3 standard deviations above the mean. If that had been a negative number, then we'd say below the mean. Okay, number 10 here. Let's go ahead and put this in the calculator and see. I have a feeling sometimes calculators round funny too, so you can let me know if this is just what happened. Well, put in all the numbers, 32, 37, 41. And it doesn't matter if you went down instead of going across like I am. We just need to put all of these numbers in here. Okay, I'm going to pause this so you don't have to watch me. Okay, so I put those all in there so you didn't have to watch the whole thing, but just put all the numbers in. And we're going to hit Stat, go over to Calc, and one variable Stats. And we're going to look at the 5 number summary here. Okay, so here's our 5 number summary. So 32, 56, 69.5, 80, and 99. So that matches up with this one right here. It looks like you chose this one, which the only difference I'm seeing is that this number is 79 instead of 80. So I don't know if your calculator rounded wrong or whatever, but let me know what happened there. Okay, 12. Okay, so here's the one, random sample, simple, random sample. A researcher obtains an alphabetical list of 2,560 students at a college. She uses a random number generator to obtain 50 numbers between 1 and 2,560. She chooses 50 of the students corresponding to those numbers. Does this sampling plan result in a random sample, and then does it a simple random sample? Now, here where you're just like using a random number generator to pick numbers, it's kind of like drawing out of a hat. This is the most random you can get. So this is random, and it's simple random. When you don't have simple random, when you start like dividing people into different groups and then picking some, or only taking the like every third person or something, that's when you don't get a simple random sample. But this is the only case I've ever seen where you do get a simple random sample, where you're literally just choosing random numbers and then picking those people. Okay, identify which of these types of sampling is used: random, stratified, systematic, cluster, or convenience. So it says a market researcher selects 500 drivers under 30 years of age and 500 drivers over 30 years of age. So you picked cluster, and here cluster and stratified are very similar. So in both of these methods, you're dividing them into 2 groups. So here we have drivers under 30. Drivers under 30. And drivers over 30. I guess they're not doing anyone who is 30, but that's okay. So anyways, here, for this problem, they're taking some from each group, right? They're taking 500 from here. So let's say, this is 500 people and 500 from here. Now, when you take some from each of the groups, that is stratified. It would be cluster if instead you took all of the people in one of the groups. So if they said they took all the drivers under 30. Okay, so that's when you divide them, and instead of doing some in each of them, so this is stratified, where if we just, let's say we had a bunch of groups, probably makes sense with more than two, and you picked some of the groups and did all the people in those groups, then that's cluster. Okay. Does the frequency distribution appear to have a normal distribution? And explain. So remember, the normal distribution is one where it starts low, goes up, and comes down again. And so we're looking at these numbers, the frequency numbers, and notice, so if we made like a histogram of this, it would be at 1, and then 0, and then 4, and then 12, and then 9, and then 7, and then 1. And since it doesn't come down and we've got the 0 here, it kind of has this gap and it's not nice. And, a normal histogram, it would have to start low, go up, and then come down in exactly the same way. So since especially we have this gap and it doesn't, it's not symmetric, meaning it's not kind of the same on each point of each side of the high point, then it's not normal. Okay. So here it says use common sense to determine whether the given event is impossible, possible but very unlikely, or possible unlikely. So Andrew rolled a dice 5 times and got a 6 every time. So we know it's not impossible, right? And when we just have one dice, like we talked about in the lab, if you're just rolling one, any of them are likely. It's like a 17% chance. But here we're talking about getting a 6 5 times in a row. And you don't have to know how to find the exact probability. We'll actually do that next week. But the probability of that would actually be really small. It would actually be 1/6 raised to the 5th power. So here, now this is scientific notation. So this means 0.0001, which would be 0.01%. So 1/10% chance of that happening. And you can think about it. If you rolled a dice 5 times and got 6s every single time in a row, you'd be very, very surprised. So, I think these were very common mistakes to make. So you definitely shouldn't feel bad about any of them. Please email me if something in this video doesn't make sense, and I'll try to focus on that problem a little bit slower. But I would recommend taking it again, and then we'll go from there. Okay? Have a great day.